Suppose we've now collected data and we want to present the information to somebody else. We don't simply want to give them the raw data. We want to create visuals or do some computations that help people understand the data without having to look at the actual raw data. So remember, we have both qualitative and quantitative data to deal with. We're going to start here with some qualitative data. So with qualitative data, there's going to be three things that you're expected to do. You should be able to create a frequency table, which is what you see here. You should be able to create a Pareto graph, which we'll talk about next, and you should also be able to create a pie chart. We'll start with the frequency table. Suppose I polled the class on what type of car each student drives. And let's say one person says Nissan, the next person says, say, Toyota, another person says Jeep, another person says Nissan, Toyota, et cetera, et cetera, et cetera. This set of all the car makes that students drive is the set of raw data for the class. Now, I can't simply, you could, given that the class is fairly small, I'm not going to simply give somebody this set of raw data and say, oh, what's going on? You've got to summarize it in some way. So you can see here, we've got Toyota, Honda, Volkswagen, Jeep, Nissan, Hyundai, and other. I'll explain other in a little bit. But ultimately, we need to be able to tell people how many there are of each. How many there are of each is what we call the frequency. So I'd go through this raw data and count it all up. And in this case, Toyota, there were 2 of them. Honda, there were 3. Volkswagens, there were 4. Jeeps, there were 3. Nissans, there were 2. Hyundai, there were 2. And there were 5 other ones. In statistics, we use lowercase f to represent the frequency. Now down here, you see a Greek letter next to that letter F for frequency. That Greek letter is the Greek letter sigma. In mathematics and statistics, sigma represents a sum. So if you recall, finding the sum of a group of numbers is adding them all up. So this is basically saying, this entire thing, find the sum of the frequencies. Sum of frequencies. Well, let's actually do that. So we've got 5, 9, 12, 14, 16, 21. So we've got a total of 21 cars or 21 students in this particular class. Now, we often in frequency table will also present the relative frequency. Relative frequency is the percent of the whole. We use the letters RF to represent relative frequency. So the percent of the whole for Toyota would be, there's 2 Toyotas out of a total of 21 cars. So the answer would be 2 21st, or 2 over 21. There would be 3 out of 21 Hondas. There would be 4 out of 21 Volkswagens, 3 out of 21 Jeeps, 2 out of 21 Nissans, 2 out of 21 Hyundais, and 5 out of 21 are other cars. Basically, the reason I use an other category here, this is actual data that I collected from a class in the past. The reason I used other is there were 5 different single cars, like cars that didn't show up here, such as Chevy. There were 5 different types of cars, and I didn't want to have 5 more classes of data, so there'd be 5 more rows to the table, or 4. So instead, I grouped these all together into 5 other types. Now, often, this fraction will be written as a decimal or percentage. It doesn't matter. You could write it as a fraction, you could write it as a decimal, it doesn't matter. So let's just write a couple of them. So let's write a couple of them as decimals and percents. So 2 21st is approximately 0.095. Or if we converted that to a percentage, that's 9.5%. 3 21st is approximately 0.143. Or 14.3%. And you could do this all the way down, but it doesn't matter to me. You could write fractions, decimals, or percentages here. Ultimately, what do you think this means? If RF stands for relative frequency, and sigma stands for take the sum, then this is saying take the sum of the relative frequencies. So if you add all these fractions up, you get 21 over 21. And 21 divided by 21 reduces to 1. Does that make sense that we got 1 there? That 1 is representing the whole, the entire class. So yes, we should have gotten 21 out of 21 there. Suppose you'd added up the decimals. So suppose you finished the decimals here and added those up, or you finished the percentages here and added those up. What should it give you? Well, the equivalent decimal form of 1 is 1.0, and the equivalent percentage form of 1 is 100%. However, it is possible that you might get something like this, say 99.7%. Does that mean that you did something wrong? It may mean something's wrong, but if it's a number close to 100%, that does not mean it's necessarily wrong. And the reason is this. Notice that these are approximations. 3 divided by 21 is approximately 0.143, which is then approximately 14.3%. So 14.3% is an approximation of 3/21. So anytime you round, you create error. And then if you round several times and then add all those things up, you could compound the error in some way. So ultimately, if you're doing this with decimals or percentages, don't be shocked if you got around 101, 101% or 99%. However, if you got 85% or 114%, then you know something is definitely wrong. We've created a frequency table representing the makes of cars driven by students in a class. Now you might be saying, well, this really doesn't necessarily look much simpler than this raw data set. Imagine instead of 21 cars, there were 21,000, or let's go even higher. There were 21 million cars. That means you got 21 million names. By tallying them up, which is getting the frequency, how many there are, and just writing how many there are in each of these rows, that is much, much simpler than reading 21 million words. Also, the relative frequency, which is often presented as a percentage, is a nice way to tell people how many there are or what percentage of people in that group drove, say, a Honda or a Toyota, so on and so forth. Let's now look to create some visuals other than numeric computations in a frequency table. Once you've completed a frequency distribution table, you'd likely want to present the information in a visual way. One of the visual ways that you're expected to be able to present qualitative data is through a Pareto graph. And a Pareto graph is just a nice fancy name for a bar graph for qualitative data. So we're going to create a bar graph. Now there's 3 particular rules that you got to keep in mind as you create the bar graph. One is that the bars do not touch in a Pareto graph, specifically in a bar graph for qualitative data. With quantitative data, the bars do touch, but bars do not touch in a Pareto graph. Bars should go from tallest to shortest, from left to right, that is, and bars are all the same width. And when you're going to create a Pareto graph, you can either put the frequency or the relative frequency on the vertical axis. Unless it says to specifically use the relative frequency, I would recommend using just frequency, since relative frequency would be represented by a decimal. The frequency is just easier to work with. So here, I don't have the entire table that we did in the previous screen. I have just the car make and the corresponding frequencies. We want to now draw a graph representing this data here. So our frequencies on the vertical axis, our horizontal axis is going to have our car makes. And so we don't have to write out the entire names, let's abbreviate each of these. So we'll use T for Toyota, H for Honda, V for Volkswagen, J for Jeep, N for Nissan. Can't use H again for Hyundai, so let's use Y. And O for other. Now, we don't simply put those names in alphabetical order. We need to put them in order from the highest frequency to the lowest frequency. So notice the other has the highest frequency. So we're going to put O first for other. And then the next highest frequency is Volkswagen. So we'll put V next. Then there are a couple of 3s, that's Honda and Jeep. Now when there's some of the same, it doesn't matter. If you did Honda first or Jeep then Honda, doesn't matter to me. And then notice there are 3 2s. You've got Toyota, Nissan, and Hyundai. So Toyota, Nissan, and Hyundai. And now we're going to draw bars at each of these names up to the height of the frequency. Well, we got to look and see what our frequencies are so we can create a scale on our vertical axis. Notice our highest one is 5. Now, of course, just like in algebra or any other time you were drawing some graphs, this frequency at the origin is 0. And we got to go up to a height of 5, so we might as well count by 1 since it's not far away. We've got 1, 2, 3, 4, 5. The other category has a frequency of 5, so that means we want to go up to the height of 5 here. You don't have to color them in, but if you want to. That is our other bar. Our Volkswagen bar should go up to a height of 4 because the frequency of Volkswagen here is 4. Well, remember, it should be the same width and they should not touch. I'm doing it by hand, so they're going to be roughly the same width, but make sure they don't touch. The Honda bar should be a height of 3. The Jeep bar is also a height of 3. And the rest are a height of 2. There were 2 Toyotas, there were 2 Nissans, and there were 2 Hyundai. We just created a Pareto graph representing this data. What's nice about that is while yes, there are still some numbers here, at least somebody that might be uncomfortable with mathematics or arithmetic, they can at least look at it and say, okay, there was the most category was some other thing, but of the cars that weren't grouped together in other, Volkswagen was the most, and Toyota, Nissan, and Hyundai were the least. But notice it's pretty spread out. So you can see how spread out the data is, so on and so forth, as you create visuals like bar graphs. Now, these are all supposed to be the same width. Of course, you don't actually see that. This is clearly wider than this one here. So we also want to be able to create Pareto graphs with Excel. I will be showing you how to do that in the coming video. So we've created a bar graph representing qualitative data. The formal term for that is a Pareto graph. You also should be able to create a pie chart. And notice it's already been done here and it's color coded. So the other category, this color blue right here, makes up 24%. The Volkswagen makes up this yellow category here, which is 19%. And notice these percentages are precisely the percentages that were the relative frequencies in our frequency table. So we create a pie chart and you can see that, for example, this yellow wedge is a bigger wedge than this blue wedge right here, or this brownish color wedge right here, or this color wedge right here. So you can do comparisons of the relative size without having to do a lot with numbers. You can see pie charts in a variety of mediums. Now, a pie chart, I'm not going to expect you to create that by hand. I will show you how to create a pie chart with Excel in a coming video.